recording now. Okay. So, very first thing I want to do is I want to make sure you all realize we have a test on Thursday. I want to make sure you understand what's going to be on that test, okay? So, test Thursday. It's fairly straightforward what to study. Okay. Basically, what's going to be on this test is all the differentiation rules, okay? So, just basically, it's totally just going to be on the derivative. And you'll want to know, first, the definitions. So, 2, how to find the tangent line. Okay. Third thing are all the rules, so the basic rules. And those rules are the power rule, product rule, okay, quotient rule, and one we're going to learn today called the chain rule.
Bang. Are you in your room?
I can be.
That'd be super.
Okay. I won't be here for the entire evening, but I can definitely be here for some of it. Okay. We will. I've got plenty of time, and this is happening Thursday, so definitely come see me during regular consultations.
You should have a meet the kid day.
All right. Last. Yes. Okay. Lastly, there's going to be all the special derivatives, so the trig derivatives.
So I was meeting
Okay.
with my teacher.
Have a seat. Okay, so, derivatives of the sine, cosine, tangent, cosecant, secant, and cotangent. Okay. That's pretty much going to be it. I don't think I'm going to put on this test a rate of change problem, although they're pretty easy. Okay, I think I'm just going to leave that off. And just stick to this right here.
What do you mean by rate of change?
Oh, so like average rate of change versus instantaneous rate of change?
Oh.
Maybe I'll ask you something easy about that, okay? And just help you out. But really, I want to stick to this for this particular test, okay? Any questions about what to expect?
No.
It's fairly straightforward. Just, be able to do all these things. The definitions, so those are the only limits you'll see is from the limit definition of the derivative. How to find tangent lines, the basic derivative rules, power rule, product rule, quotient rule, chain rule, and lastly, derivatives of your trigonometric functions. Okay? Any questions about that?
Have we gone over the chain rule yet?
We're going over it today. Okay, right after we're done with this, okay? Alright. That being said, let's go over the chain rule. Okay, we're going to do that before we do anything else. Okay? You've actually already seen the chain rule before. Okay? The chain rule is something you saw. Use the tissue box. Okay. Chain rule is something that we've seen actually when we've done these trig derivatives. Okay, for example, sine of 3x squared up here is cosine of 3x squared times 6x. Okay, that's this derivative. That's actually a use of the chain rule. Okay, so let's quickly go over what the chain rule is. Chain rule is how to take is basically the way to take the derivative of a composite function f of x, f of g of x. Okay? So basically, the derivative of that is going to be f prime of g of x times the derivative of g of x. Okay, so a derivative of derivative of f of g of x times the derivative of g of x, basically, is what it comes out to. All right. You can almost think of it, and when we see an example here, I'll make it clear what we're doing. You typically see this rule used for functions that are in parentheses. Okay, so you have something in parentheses being raised to a power. That's typically what you use the chain rule on. And essentially, you treat the outside part as if it's a regular function, which you're taking the derivative of, leaving the inside the same. And then when you're done with that, you multiply it all by the derivative of the inside. Sort of, again, same exact thing we've been doing up here with the trigonometric ones. We took the derivative of the sine, leaving the angle part the same, and then multiplied the result by the derivative of the angle part, right? That's exactly a chain rule, okay? Let's look at an example, though, okay, with an actual function here, okay? So an example, okay? Let's do the derivative with respect to x, excuse me, of 5 times the square root of x cubed minus 4x.
When we do the derivative, do we have to write out the d over dx?
Well, it depends. Usually that's part of the problem. So usually you're just given derivative of this. Or you could also do f prime of x.
F prime, okay.
Okay, those are both different. It's just different notation. Yeah.
Isn't that only one function now?
Well, it is only one function, but I can treat it as if it's a composite. Okay. I can treat it as basically g of x being x cubed minus 4x, and the f of x that I stick that into being 5 root x, if you will. Okay? But how I'm really going to think of this thing is basically, the first thing I'm going to do is, and this is something I should have told you a while back, we do not like the radical symbol in calculus. We'd much rather have it be a power. So anytime you see a radical, go ahead and convert it to a power. So what's the square root equal to as an exponent?
1/2.
1/2. So we'll go ahead and change this to be the derivative with respect to x of 5 times x cubed minus 4x to the 1/2, like so. Okay, what I'm going to do is I'm going to think of this stuff in here as basically just being x, okay? In which case, this thing would then become 5 x to the 1/2 power, right?
Yeah.
And I can do the derivative of that easy, correct? That's a what? It's a simple power rule, right? What's the derivative of 5 x to the 1/2?
5 over 2 to the negative 1/2.
5 over 2 times x to the negative 1/2, right? But remember, it's not x here, it's x cubed minus 4x. So you see here, this is that same thing we're treating as x in here, okay? But we're not done yet. Because this isn't x, this is x cubed minus 4x, we have to account for that. And we do so by multiplying this entire thing by the derivative of what's on the inside. So what's the derivative of x cubed minus 4x? 3x squared minus 4. Okay? And this right here, okay, is my answer. That's the derivative using the chain rule.
Wait, why do you just, wouldn't the 3x squared minus 4 replace? Wait.
It's not, it doesn't replace the stuff on the inside. It's tied on the outside. Basically, again, I can think of this as being, if it helps here,
So you're adding the g of x, that's the g of x part from the definition.
right, so you can think of this as being g of x,
Okay.
and this is f,
This.
okay, of g of
minus
x.
1.
So here,
This is that.
oops,
1/2 minus 1.
this is f prime of g of x, g prime of x I'm multiplying it by. Okay? Is that clear what's going on there? Okay, I should have, undo that, I'm going to do it. Alright, there we go. Okay, and it should be a little clearer what's going on there. Okay? That's your chain rule for you. Now, some functions you don't necessarily have to do chain rule on, and some you could really only do the chain rule on. Like this one, for example. Was there any other way I could have done this? Can I expand a 1/2? No, right? It's just kind of, I'm sure there's some way, but it would be ugly and not very fun, and it would take forever to do. Okay? It's much easier just to go ahead and use the chain rule to figure out its derivative. Okay? But typically speaking, when I have something in parentheses like this, raised to a power, that's a sign I'm going to be doing the chain rule to it. Okay? Has everyone got that? Let's look at some more examples. Okay? Another example. Let's do f of x equals 15 times 3x squared minus 4x plus 2 to the 10th power. Okay, we want the derivative of this. Okay. In theory, can I expand this out and use the power rule?
Yes.
Yeah.
Yes. In practice, am I going to try to do that? Why?
Because x to the 10th is
X cubed, 3x squared minus 4x plus 2 to the 10th power would be ridiculously long to expand. Okay? There's no. We don't want to try to do that. We don't want to be here all afternoon expanding a single trinomial left. Okay? Because again, this is not something you can use Pascal triangle to. It's not something easy we can work out. It's going to be there, sitting there, slogging through it all. Okay, so this is even though this is something you could in theory expand, you're going to want to use the chain rule to it, and the chain rule makes it go really quickly. Chain rule says I treat the outside as if it's a regular old function. So if I think of it that way, this would be using the power rule on the outside. It would be what? 135.
135.
That's right.
It's 10 times 15, which is 150. Keep the, well, just ignore what's on the inside. To the 9th. Now what went on the inside? 3x squared minus 4x plus 2. Okay, so far so good. To finish it all off though, I gotta multiply it by the derivative of the inside, which is gonna be what?
6x.
6x minus 4. Boom.
There we go.
That's it.
That's it. And remember, you don't have to go any further. This is as far as you need to go. Yes. Okay. As far as simplification is concerned, this is going to be how it works in the test on Thursday. Unless you are explicitly told to take things further, the second you do whatever action you're being asked, you're done. So I've taken the derivative here. This is my derivative. I don't need to go any further.
Could there be a question like that?
Why? Would go further? Yeah, there could be a question like that. Could be usually how you would go further. You might be asked to evaluate this at a number.
Which means find the tangent line at x equals 2.
Yeah. In which case, I would need to plug in 2 to this and actually get a numerical answer out.
Yeah.
Okay.
So that's what you
Now, I won't have you do that on something this ridiculous. Okay. But that would be one case I would go further. But as far as the derivative is concerned, if I just say take the derivative of this, you're done. Okay. What was your question, Derby?
it was answered.
Okay. So that's how the chain rule works. Notice too, by the way, I kept saying this before, these trick things are also chain rules. We took a look at an example of one.
Let's see.
Okay. If I had, for example, asked you to take the derivative with respect to x of 3 tangent of 5x to the 4th minus 4x. Okay? I would again, this is a chain rule. I take the derivative of the tangent part, leaving the 5x to the 4th minus 4x alone. Then after I'm done with that, I take the derivative of 5x to the 4th minus 4x. What's the derivative of the tangent? Anybody remember?
Negative sine minus cosine.
No.
Back.
Okay. Gotta learn these. Yes.
Cosine over sine.
Well, so the tangent is sine over cosine.
Negative cosine over
Oh,
sine.
in that case.
Is it negative sine?
No.
Or is it cosine over negative sine?
It's
No.
negative cosine.
No.
Negative.
Alright,
negative.
Just keep
let's
guessing.
just go ahead and do it. Okay. These are all, by the way, all differentiation rules you need to know for the test. Okay? Are on page 136.
Sine over cosine.
Okay? They're down there at the bottom of 136. To go over this with you again, I'll go ahead and just re-go over all the trig rules today, because maybe we may have forgotten them between now and over the weekend.
You did.
But the derivative of the tangent
We actually
is
didn't go over it.
secant squared. Okay?
Is?
Yes, that's what it is. Did we not go over this?
No,
I don't think we did.
Okay, well, we're going to go over it
I
now.
don't think we went over it Friday.
That was it, yeah.
We didn't go over it.
Don't you try to pull that on us, Mr. Dowell. Come on.
You lost something there.
Drop something.
Okay, yeah, the cat fell off. Alright, well, it turns out the derivative of the tangent is the secant squared. Okay, and so notice here, I took the derivative of the tangent, okay, or 3 tangent, which is 3 secant squared. The angle, the argument here didn't change. It remained 5x to the 4th minus 4x, and then I took the derivative of that and multiplied it to everything at the end, okay? And so that's how we ended up getting this answer. But note, that's the same exact thing I've been doing with all these tangent line problems, or all these chain rule problems. Okay? Because these trig functions are chain rules every time you hit them. Okay? Any questions so far? Besides the obvious, what are the trig identities you need to know?
Well,
Yes, we're gonna do it
sine
right
is
now.
negative cosine.
You gonna give us trig identities to the test?
Oh yeah, here we go
Like-
there.
Oh, like you're gonna give them to us?
Oh no, you have to know them.
Okay.
Yeah, I'm not giving them to you.
Jeez, that would have been.
Sorry. Alright, let's go over those real fast, okay?
Made my life easy.
Anyway, any questions about what I've got up here so far? No, good. Okay. So, just as a quick reminder, or because I guess I didn't go over it over the week the other day, the full out 6 trigonometric derivatives.
We didn't go over this Friday.
I guess we just ran out of time or something. Okay. All right. We already know the sine and the cosine, right? What's the derivative of the sine of x? Cosine of x dx. Okay. That dx again is just basically just saying I'm going to do the chain rule to it. Okay. And what was the derivative of the cosine?
Negative sine.
Negative sine. Good. Yeah, minus sine of x dx. Okay. The other 4 we can actually get, okay, with the current crop of differentiation rules we have. If I apply some, for example, the quotient rule, I can figure out the derivative of the tangent. I can figure out the derivative of the secant, the cosecant, and the cotangent. Okay, because they all end up. Because remember, tangent, for example, is sine over cosine. Well, if I use that, basically, if I did the quotient rule to that, I get an answer which would happen to be the derivative of the tangent. Okay, cosecant is 1 over sine. Again, I could just use either my the quotient rule, or I can now actually use the chain rule on it as well, because I could rewrite that as the sine of x in parentheses to negative first, and go that way. Okay, but it's a lot easier instead of having to write them each time, which you can, to just go ahead and learn what they are. So we'll go through the list real fast. The derivative of the tangent of x, you just saw it in the previous problem. It was
Secant squared.
secant squared of x dx. Okay. Now, for kind of the doppelgangers, the evil twins of all these, the derivative with respect to x of the cosecant of x is going to be a little wacky. It's minus the cosecant of x cotangent of x. Okay? The next one, the derivative with respect to x of the secant of x is the secant of x tangent of x. Okay? And the last one, the derivative with respect to x of the cotangent of x is minus the cosecant squared of x dx. These are all dx's in the end, by the way. So again, they're just chain rules.
So if
Okay.
you don't remember to put the dx at the end, it's wrong.
Again, I'm never going to just straight up ask you to do this, to regurgitate this.
Yeah.
Instead, I'm just going to be asking you to use it. So I might give you a problem like give me the derivative of the secant of 3x. Okay? Well, the derivative of the secant is the secant tangent, so it's going to be the secant of 3x times the tangent of 3x, okay, times whatever the derivative of 3x is, which is 3. And so that's my answer. Okay?
Oh, okay.
That's what the dx there stands for. Okay? I just will account for that. It's basically telling you I'm going to do the chain rule to these things. Okay? But these are the 6 trigonometric derivatives. Okay? Now, they seem rather strange, a few of them. Okay? There is sort of a weird, twisted logic to them. Okay? And again, all of these, except with the exception of the first two, the tangent, cosecant, secant, cotangent can be derived using the derivative rules we learned on the sine and cosine. Okay? So, but notice here, if it starts with a cosecant, or cosine, cosecant, cotangent, if it starts with a the answer has a negative sign in it. Okay? If it, the tangent and the secant go hand in hand. Just like the cosecant and the cotangent go hand in hand. Okay? Other little things. I mean, there's like lots of little tricks you can use to remember them. But that's basically...
Is there a song?
Nah, I don't know of a song.
Oh, there's a song.
I'm sure there is somewhere. I'm sure someone's created it. Or created an acronym like the whole SOHCAHTOA thing for knowing the how the right triangles work and things like that. Okay?
That's the least of it.
Or like some old horse caught another horse taking oats
That's
away.
a good question. So what?
Oh, that's how you can remember like the sine. Sine is opposite over hypotenuse. Some old horse caught another horse taking oats away.
So
It's a
caught
mnemonic.
another hippie tripping on
There's
acid.
other ones like that that are less PC. Or I should say are more PG-13. That I'll tell you later. Anyway,
Tell me when I'm 13.
but this is the these are those trigonometric identities. Again, when you're trying to remember these, they are all right here. Page 136. Okay? It's in page 136, right there. Booyah. Everyone see it? 136? Right there. Okay. And those are all the rules you need to know. Basically, if you know everything in that box and know how to use it, you'll do great on the test on Thursday. Okay? The only thing that's not in that box are the 2 definitions involving limits, which we'll go over. The whole,
Anything about limits or nothing?
well, just these. Remember the definitions of the derivative?
Yeah, okay. That's a good question.
Are you gonna write this down right now?
Yeah.
Yes.
Okay. For a function, f prime of x, remember, is equal to the limit as h goes to 0. Excuse me, not x. I always do that. H. Don't want to do that. H goes to 0 of f of x plus h minus f of x.
Are we gonna have to regurgitate this?
Yes. Okay.
Wait, what?
And the other one is for points, for at a point. Point x equals a. It's f prime of a is equal to the limit as x goes to a of f of x minus f of a all over x minus a. Those are the 2 definitions of the derivative. I remember I said you absolutely had to know. Because again, there's very few like definitional or theory things that they throw on the AP, but this is one of them.
So on the test, we'll just have to regurgitate this.
Perhaps. I won't say, but you'll see it somewhere.
I know, Mama Bird.
You might see variations on it. Like remember too, I can always figure out the answer is using the power rule instead. So if I give you something ridiculous, okay, you could always, in the form of this, you could go, well, wait a minute, the back end of it is f of x, and if I just do the power rule to it, I get the derivative. So what I mean by that, I mean I could give you something just like ridiculously stupid looking, okay? In this form right here, and ask you to figure out what it is, and instead of sitting there freaking out about it, you just remember, hey, this is the derivative, and quickly come up with your answer.
I'll remember that, because chances are I'd probably freak out trying to solve it.
Yep. Okay. It's also a common AP question. They'll give you something awful looking in this form right here. And so say take the following limit, and it'll be this right here, but it will be some function that's just terrible. And people will be like, oh my god, how am I going to work out this limit? Well, if you recognize, well, wait a minute, it's actually just in this form right here. It's a derivative, and you're done. Hint, anytime you see the x plus h in a problem anywhere, and it's a limit, it's going to be the derivative, okay, in reality.
So then we can just use the power rule and do
Yep,
that.
absolutely. Yep. Which is the way you would do that.
So we'd have the original function, so we just do the power rule of the original function.
Yeah. Or, even if you didn't, remember, that's the original function right there.
Alright.
So there'll be a part of it minus blah dilly blue, and just take the blah dilly blue and take the derivative of that.
So why-
Put a square around it and say this is my final answer.
So all you could really do is the power rule, and then when you say, now find the tangent line for a point at x equals that, at x equals 2, you plug that into your new equation.
Mm-hmm. Yep.
Told you.
In fact, let's take a look at, because it's a good exercise, and it is something that we're going to see on the test, and we're going to go over this because I have class tomorrow and on Wednesday. So we'll review this as well. But the tangent line problem, or tangent lines end up being basically a big part of what we end up doing, okay? Or what will be on the test. So let's look at an example, okay? So, find the tangent line of, and you'll generally be given some function. Let me go find a good example problem. Hang on.
This could be on the test.
Oh, this will absolutely be on the test. Tangent lines, of course they are. So this might be something from like one of the homework assignments from the other night. 55 on page 115. You're asked to find the equation of a tangent line of the following function at the given point. So the function is y equals x to the fourth, okay, minus 3x squared plus 2, and the point you're given, okay, they actually give you the full point. They tell you to do it at 1, 0, but you could just be told the x coordinate, okay? In which case, you just have to keep things back in, okay? Tangent lines, they actually have an equation, okay, that works for the tangent line. That equation is y minus y1 equals the derivative at x equals 1 times x minus x1. Okay, basically, y coordinate at whatever x I put in, derivative evaluated at the same x, and there's the x I'm given. Okay, so in this particular case here, x sub 1, that's given, it's 1. We're also given that y sub 1 is 0. That comes from her point. So the only thing I need is the derivative evaluated at x sub 1. Okay, evaluated at the x I'm given. So what's the derivative of this thing?
4x cubed.
4x cubed minus 6x. Evaluated that at 1. That gives me 4 times 1 cubed minus 6 times 1, which is minus 2. So, the f prime of x of 1 here is minus 2. That gives me all the pieces I need. Now I just feed them in. So my tangent line equation is going to be y minus 0 equals negative 2 times x minus 1. And I'm done. That's it. I don't go any further. Let's see how that works.
Yep.
Okay. Again, it was basically like those the take-home AP problems. Okay. Type of situation. Okay. A variation on this might be one where I don't give you the x coordinate. I just Alright, give you the x coordinate but nothing else.
How would we
So-
do that?
Well, let's see it real fast, okay? So, another find the tangent line. X equals negative 1. Okay?
And once you took it, Mr. Dowell, literally for like 10 seconds, you go back.
Yeah.
Alright. Alright, you get it,
Good? Alright. So,
That was to find the point of a tangent line?
that was just finding the tangent.
Finding.
Yeah, they were given the point of the tangent.
Oh, yeah, that's right, 'cause that's the.
And generally speaking, you'll always be given the point of what you're trying to find a tangent line of. Although, we'll take a look at an example where they kind of flip things around here after this one. So in this particular example, I don't have the y coordinate. I just have the x coordinate. So what do you think I ought to do first? Find the y coordinate, right? How do I find the y coordinate? You plug in x. So y then is going to be equal to negative 1 cubed plus negative 1. What's negative 1 cubed?
-1.
Negative 1. And negative 1 plus negative 1 is?
-2.
Negative 2. Okay? The other thing I'm going to need is the derivative evaluated at negative 1. What's my derivative going to be? 3x cubed squared plus 1, which evaluated at negative 1 comes out to be 3 plus 1, or 4. That's all I need. Now I can write my tangent line, which is going to be y minus 2 equals 4 times x minus 1. And that's it. Done. Don't have to go any further. I'm finished. If you feel so inclined to turn those into positive signs, be my guest. Okay? But that's fine. Okay. Any questions about that? Alright, good. Okay. I'll give you guys a chance to copy. Okay. The next, huh? Oh, back one more? Yeah. Okay. The probably like the craziest, most complicated problem you might see might be ones like 65 on page 116, where you're missing a thing and you're trying to solve for the value. So on this problem here, okay, we've got x squared minus kx, and we're told the tangent line for it is 5x minus 4, okay? And what we want to do here is we want to figure out what k is, okay? Now, this is going to, a problem like this takes some kind of thinking through what you have to do here. In order to find k, there's some things I've got to know. First and foremost, the tangent line and the function, they share what? The same what? What has to be the same for both?
The x.
Yeah, the x, the point of tangency, right?
Right.
So, that means if the x's are the same, and technically the y's are the same as well, x squared minus k of x, or x squared minus kx, must be equal to 5x minus 4. Now that's great, I got one equation I can work with, but I have two unknowns there, right?
Yeah.
So I need something more, okay? Okay, what about the derivative?
Take the derivative of 5x minus 4.
Okay, well the derivative of this guy is going to be equal to what?
2x minus k.
Okay? The derivative of this, 2x minus k, is, what does the derivative ultimately represent? It's the what? Slope of the tangent line. Well, there's my tangent line. What's its slope?
5.
So, the derivative,
No way. It's not possible.
2x minus k, is equal to the slope. So I have another equation now. 2x minus k equals 5. And now, aha, two equations with two unknowns. I can now solve this, can't I?
No.
Okay?
Yeah, don't be silly, buddy.
Alright, you can totally solve this. Now, I've actually done this problem already, two different ways. Once where I solve for k directly, it gets really nasty really quickly. And then once while you solve for x and then take your answer for x and solve it for k, which ends up being a lot faster. Okay? I'm kind of doing it the more circuitous way. So, what I'm going to do is, I'm going to solve for k in this bottom equation, and then use substitution into the top one. Okay, and then I have only x's, which end up being faster to solve. This is fairly easy. If I just switch these, right, I get my, I get what k is. So that's what I'm going to do first. 2x minus k equals 5. I'm going to flip those things, so it'd be 2x minus 5 equals k. Substitute that in for the k up there. Okay. Whoops, left out an x, sorry. There we go. Now it's just a matter of cleaning up. What's going to fall away from both sides? Those will cancel. What does this clean up to be? Minus x squared equals minus 4. Okay? What can I drop from both sides? The negative sign. So x squared then is equal to 4.
Plus or
So
minus
x
2.
must be equal to plus or minus 2. And I'll take that answer, plug it in right here. 2x minus 5 equals k. When x is 2, what's k going to be? Negative 1. And when x is negative 2, what do I get? Negative 9. So the k up there must have been negative 1 or negative 9. It's okay to get two answers, it just means there's two functions with that tangent line. Okay? And that's how that works there.
That's all I have to say
Huh?
about that.
That's how the cookie crumbles.
That's how the cookies crumbles. That's all I have to say about that. That's all she wrote. That's the bee's knees. That's whatever thing you want to know. All right. Should be some review problems and some homework on Canvas. Go ahead and do that. And study hard. That test is coming up. Okay? It's Thursday.
Will you please be in your room?